Welcome back to my class. In our earlier few classes, we have already played with a 2-digit number, 3-digit number. We have checked the divisibility of a given number by some other number. Now, in today's class, we will be solving some miscellaneous exercises based on the concept, the theory that we have already learned in our previous classes. So, let's get started. The first problem, it states that if sum of the number 985, so this is the given number 985 that based on which the problem is formed, so and two other numbers obtained by arranging the digits of this number 9, 8 and 5 in cyclic order, and that is divided by 111, separately 2 and separately 37. So we have to find the quotients in each case without performing the real division. Now the number is 985. So what we have to do is we have to change the digits, their positions in cyclic order. So either we can go in clockwise direction or we can prefer to go in anti-clockwise direction. Suppose if we go in clockwise direction, then 9 clockwise means in this direction. So 9 will come here, then 8 will go here and 5 will go there. So the first number was 985 and then the second number will be 5, 9 and then 8, and then further we will move the digits in cyclic order or in anti-clockwise direction. So 5 will come here, then 9 will go here and then 8 will go in the position of 5. So the new number will be 8, 5, 9, because initially we started our journey from this position, so always it will be from here on. So it will be the third number will be 8, 5, 9. Now what we can do is we can add these three numbers and then we can divide by 111 or maybe separately 22 or maybe 37, and then we can find the quotient. That is one way, that is the normal way how we add or divide. But in our theory class, we have learned that if we have such 3-digit number and if we rotate the digits of that number, the given number in cyclic order, then the summation of those three-digit numbers, finally it comes as 111 multiplied by the summation of all those 3 digits. That means here it will have the summation, the result of summation will have two factors. One factor or one of them will be 111 and the second factor will be a plus b plus c, means here 3 digits are 9 plus 8 plus 5. So it will be 111 and 8 plus 5, 13 plus 9, it will be 22. That means if we divide this result of addition by 111, and definitely the quotient will be 22. So the first part, when we will divide by 111, the quotient will be, we can easily answer that the quotient will be 22, and that we are answering without performing the real addition and division, and the trick we have already learned. Now the second case, we are dividing that same result of summation by 22. Now if we divide by 22, the quotient will be 111. Now in the third part of that problem, we are dividing by 37. So what will be the quotient? Now here if we further factorize this, then 111 we have already seen that can be written as 3 multiplied by 37. So finally it will have 3 factors. So 37 3s are 111. So when we will divide that result of summation by 37, then the quotient will be the multiplication of rest of the factors, which are 3 and 22. So it will be 3 multiplied by 22, that means 66. So this is our result. So when we will be multiplying by 111, the result will be 22. When it will be by 22, the result or quotient will be 111, and when we will be dividing by 37, then the result will be 66. Now the second exercise says that find the quotient when the difference of 985 and 958 is divided by 9. So here the first number is 985 and the second number is 958. And what we need to do is, what will be the difference of these two numbers, and that result of the subtraction or that difference we will be dividing by 9, and we have to answer the what will be the quotient. We can perform this by simply subtracting these two numbers and then by dividing 9. But there is another trick that we have already learned in our theory class, that here what we can see is that the digit that we have at hundreds position or at this position from right, this digit is, these two digits are same, and that is 9. Only these two digits at units place and tens place, they are different, and still there is a relationship between these two digits, between these two numbers. So the first number is 85, and in the second number the digits are 58. That means we have just interchange the positions of these two digits. And in our theory class we have learned that suppose if we have a two-digit number AB, and if we interchange the positions of the digits and if we get a new number BA, now if we subtract BA from AB, then in the result of subtraction we get two factors. One of the factors is 9 and the second factor is A minus V. So here the third digit we are not changing, we are not doing anything with that. We are changing the position of the first digit and second digit. So this part of the number what we have on the right side, they separately will be considered as a two-digit number, and on that we are performing the subtraction. So here when we will be performing the subtraction on these two numbers 85 and 58, we will be, in the result of subtraction we will be having these two factors. That means one of the factors will be 9 and the second factor will be A minus B. So here the digit which is higher or has the higher value, that is 8, and that has smaller value, that is 5. So here it will be finally 9 multiplied by 3. So in the result of subtraction we will be having these two factors only, and now that result of subtraction we are dividing by 9. So the quotient could be what? Very simple. The quotient will be the other factor, that means 3. So here the answer will be 3. So if we know the trick, we can answer within second. Now next problem sum says that find the remainder when this given number is divided by 3, and that too we have to do without performing the actual division. So the number has in total 8 digits, and that we will be dividing by 3, and that will be completely divisible. And we know the rule of divisibility by 3. If the summation of all the digits of that given number, that sum is divisible by 3, then the whole number is divisible by 3. So if we want to know that if it is not completely divisible, that means there will be a remainder. We have to find the remainder, but before that we have to add all these digits, all the digits of this given number. So it will be 5 plus 1, 43. So 43 now we will divide by 3. 43, if we divide by 3, then the quotient will be 14. 14 3s are 42, so the remainder will be 1. That means if we divide this number by 3, if it is not completely divisible, then there will be a remainder, and that remainder for this particular number, that remainder will be 1. And this is how we find. Now the next problem sum says that a number is given but all the digits are not mentioned. Here the digit in tens place is represented by x. The real value is not known, but that number is completely divisible by 4, and if it is, then we have to find all the possible values of x. Now before solving this type of exercise or problem sum, we have to know the rule of divisibility by 4, and that we have already learned in one of our earlier classes. We know that if the sum of last two digits of a given number, if that is divisible by 4, then the whole number is divisible by 4. And why? That rule we have already learned. So here the last two digits means x and 2. So x is at tens position, so it will be 10 multiplied by x, and then the digit that we have at units place, that will be added. So if we only consider if these two digits and if we take the sum, then it will be 10x plus 2. And if this whole number is divisible by 4, that means 10x plus 2 will be divisible by 4. Now we have to see what could be the possible values of x, so that 10x plus 2 will be completely divisible by 4. Now here x is a digit that can take values from 0 to 9, right? So now suppose if we assess this number, this part one by one from 0 to 9, then the first value of x that we can put here is 0, and if we do that, then the value of this summation, this of these two digits will be 2. But we know 2 is not divisible by 4. That means 0 is not, we cannot put 0 here in place of x. Now the second possibility is if x is 1. So if x is 1, then 10 plus 2, it will be 12. Now if we divide 12 by 4, the quotient is 3 and remainder is 0. That means when x will have 1, that number will be 10x plus 2 will be completely divisible by 4, and the whole given number will be divisible by 4. Now the third value that it can have, x when x is equal to 2. When x is equal to 2, it will be 20 plus 2, 22. 22 divided by 4 is not, it will have remainder, so it is not divisible by 4. The fourth possibility is x is equal to 3. X is equal to 3 means, 30 plus 2, 32. So 32 divided by 4, the quotient is 8 and there is no remainder. So when x is equal to 3, then that number is divisible by 4. So that is also possible. So when x is equal to 1, that was completely divisible by 4. When x is equal to 3, that is also completely divisible by 4. Now the next possibility, when x will be equal to 4. When x is equal to 4 means it will be 42. 42 divided by 4. So 42 divided by 4 is not completely divisible by 4. So that is not possible. Next possibility is 5. 5 tens are 50 plus 2, 52. So 52 divided by 4, the quotient is 13 and the remainder is 0. That means when x is equal to 5, so that this number will be completely divisible by 4, this part, and the whole number will be completely divisible by 4. The next possibility is when x is equal to 6. So it will be 60 plus 2, 62. 62 plus 4, it is not completely divisible by 4. Then the next possibility is 7. So 7 tens are 70 plus 2, 72 divided by 4. So it will be 18. 18 means it is completely, and there is no remainder, so it is completely divisible by 4. Then the next possibility is 8. So when it will be 8, then it will be 82 divided by 4. It is not divisible by 4. And then the last possibility, the last value that x can have is 9. When we will put x is equal to 9, then it will be 90, then plus 2, 92. 92 divided by 4 is 23, and there is no remainder. That means this is also divisible by 3. And these are the possibilities. This is x is equal to 9, and this is when x is equal to 7. So the possible values of x will be x is equal to 1, then x is equal to 3. Then the next possibility is when x is equal to 5, then when x is equal to 7, and then the final possibility is when x is equal to 9. Now let's see what is waiting for us next. Next we see here that find the remainder when this given number is divided by 5, and do this without performing actual division. Now the rule of divisibility by 5 is, we know if at units place, if the digit is 0 or 5, then that number will be divisible by 5, otherwise not. And if the digit is something else other than 0 and 5, and if we divide that digit by 5, whatever remainder we will have, then if we divide the whole number by 5, the same remainder we will get. That means if we evaluate this number, this given number, we can see here the last digit, the digits at units place is not 0 or 5, rather it is 7. That means we can conclude that this number is not divisible by 5. Now we have to see what is the number. The number is 7. Now if we divide 7 by 5, the remainder that we will have will be 2. And the rule says, now if we divide the whole number by 5, then we will have the same remainder, and we can separately divide that, we can separately check that, though that is not part of this solution, but for our satisfaction we can test that. So we can see here that when we divide separately this given number by 5, finally we are getting here the same remainder, which is 2. But in exam you don't have to do this part, it's just, this was for verification only. If we know the rule, we can within seconds answer that will be the remainder if the number is not divisible by 5. Now the next problem sum says that the given number, if it is divisible by 9, then we have to find the possible values of y. This is same that we have solved here, the same type of problem. Now we have to, before we find the possible values of y, we have to know the rule of divisibility by 9. The rule of divisibility by 9 is same as 3. So the rule says, if the summation of all these digits in that given number, if that is divisible by 9, then the whole number will be divisible by 9. So here if we take the summation of all those digits, so it will be 6 plus 7 plus y plus 1 and then plus 9. So it is 23 plus y. Now again y can take values from 0 to 9. So we have to put these values in place of y, and we have to see what will be the result of summation when we'll add that value with 23, and then we have to see whether that will be divisible by 9 or not. So if we put 0 in place of y, the result of summation will be 23, and that is not divisible by 9. We know that, so this is not possible. So the first value, then the second value that y can have is 1. So when 1 will be added with 23, it will be 24. 24, when we will divide 24 by 9, it will not be completely divisible, it will have remainder. Then the next value that y can have is 2. So 23 plus 2, it will be 25. 25 is not divisible by 9. Similarly, we will assess with other values of y that it can have. Now the next value is when y is equal to 4. So 4 plus 23 is 27, and 27 when we will divide by 9, the quotient will be 3 and there will be no remainder. So here y is equal to 3. The next value of y is 3, so it will be 26. 26 divided by 9 is not divisible by 9. Then the next value is 4. 23 plus 4, 27. 27 by 9, it will be, quotient will be 3, there will be no remainder. That means the first possible value of y is 4. Then the next value y is equal to 5. 523 plus 528, which is not divisible by 9. Then the next value is 6. 623 plus 6 is 29, which is not divisible by 9. Then the next possible value of y could be 7. Then 23 plus 7 is 30, which is not divisible by 9. Then the next possible value of y could be 8. So the summation will be 31. 31 divided by 9 is not possible. Then the last possible value of y is 9. 9 plus 23. 9 plus 23 is 32. 32 by 9, it is not divisible by 9. So it is also not possible. That means what we can see here, that only possible value of y is 4, and for that value the whole number will be divisible by 9. Now the next problem sum says that without performing actual division, we have to find the remainder when this given number is divided by 11. Now we know the rule of divisibility by 11, that it will be completely divisible when the summation of all the digits that are there in that number in odd position and the summation of all the digits which are there in that number in even position. If we evaluate the summation separately and then if we take the difference, then that difference should be divisible by 11. Then if it is, then the given number will be divisible by 11. So let's evaluate that. So here what we can see is that in the odd position, the digits that we have are 3, then 6, then 7, then 8, and then 9. So these are the digits that we have in odd positions in that given number. So first we will take the sum of the digits which we have in odd position. So it is 33, and the summation of the digits which we have in even position, they are, and that is 2 plus 1, what we can see here, 2, 1, 4, and then 5, and that result of addition will be 12. So separately we have found the summation of the digits in odd position and even position. Now what we'll do, what I said is, we will take the difference of those summation or result of summation. So difference is what? Definitely we will subtract the value which is smaller than the value which is bigger. So here the result of subtraction will be 21. Now that result of subtraction we will divide by 11. If it is completely divisible by 11, then the whole given number will be divisible by 11. Otherwise, if it has remainder, then it is not divisible by 11. So here, if when we will divide this, it will have remainder, and that remainder is 10. So that means this given number is not divisible by 11, and that remainder is 10. Now the next problem sum says that if this given number is a multiple of 6 where y is a digit, then what could be the possible values of y? Multiple of 6 means, that means when we will divide this by 6, this will be completely divisible, there will be no remainder since this is multiple of 6. So that means we have to apply the rule of divisibility by 6, and as per that rule we know any given number is divisible by 6 when that number is separately divisible by 2 and divisible by 3. So first we will assess this number, the divisibility of this number by 3. So the rule of divisibility by 3 first we have to apply here, and that we know that when the summation of all the digits in that given number is divisible by 3, then the whole number will be divisible by 3. So first we will add all the digits in that given number to check the divisibility by 3. So here the summation is coming as 11 plus y. Now 11 plus y, if it is divisible by 3 and separately if it is divisible by 2, then the number will be divisible by 6. So again here y can have values from 0 to 9, and we will assess one by one. So when the value is 0, then this summation will be 11, and 11 is not divisible by 3. Now next, when the value of y will be 1, then this summation will be 12. So 12 is divisible by 3 and the remainder will be 0, so it is divisible by 3, that means. So here the value of y is 1. Next, the value of y when it is 2, then it will be 13. 13 is not divisible by 3. Then the next value of y that it can have is 3. So 3, 11 plus 3 is 14. So 14 is again not divisible by 3. Then the next value is 4, and 11 plus 4 is 15. 15 divided by 3, it is divisible by 3. Then the next value of y is 5, and 5 plus 11, it will be 16. 16 is not divisible by 3. Then the next value of y is 6. So 6 plus 11, it is 17. 17 is not divisible by 3. Next is 7. 7 plus 11, it is 18. 18 is divisible by 3. So that means this value is also y can have. And then the next value is 8, and 8. 11 plus 8 is 19. 19 is not divisible by 3. And the last value that y can have is 9. And 11 plus 9 is 20. 20 is not divisible by 3. That means the possible values that y may have are 1, 4, and 7. So 1, 4, and 7. And as we can see here at the unit place, the digit is 8. That means it is even digit. It is even number at units place, and this whole number is also even number. And since this is even number, so whatever the value of y is, the whole number will be always even number, and that will be divisible by 2. Only for these three values of y, which are 1, 4 and 7, the number will be divisible by 6. Now the next problem sum says that verify whether this number is divisible by 7 or not. Now to check the divisibility by 7, we have to know the rule, and the rule says that from the given number, which is 277, then 681, we will choose the digit which we have at units place, then we will multiply that digit, that number, by 2. So this result of multiplication is 2, and then we will subtract that result of multiplication from the rest of the numbers. That means we will not consider the unit that we had in the units place. Then the rest of the digits are 27768, and from that number we will subtract the result of multiplication of that digit that we had in the units place. So here the result of subtraction will be here 6, 6, then 2, 7, 7. Now again we don't know that whether this number is divisible by 7. So to check the divisibility, again we will follow the same rule. So here the digit that we have at units place is 6. So we will multiply that by 12, and then that result of multiplication we will be subtracting from the rest of the numbers. So here it will be 4, then it will be 6, then 2, 7. So 2764. Now from 2764, so again the digit at units place is 4, so it will be 4 multiplied by 2, so it will be 8. Now this 8 we will subtract from 276. Here all are subtraction. So when we will do that, then it will be 2, 6, 8. Now at units place the digit is 8, so it will be multiplied by 2. So the result of multiplication is 16, and that 16 we will subtract from the rest of the number, which is now 26. So 26 minus 16, so it will be 10. Now we don't have to proceed further in the same way, because we know by this time we can conclude that 10 is not divisible by 7. We know that. That means the whole number is not divisible by 7. Now we have similar kind of problem sum next, and that is the divisibility of a given number by 13 this time. So here the given number is 119, then 0, then 4 and 5, and we have to check the divisibility by 13. And in this case what we do is, again we choose the digit at units place, and that digit we multiply by this time 4, not 2, it is 4, so it will be 20. And then what we do is we add that result of multiplication with rest of the numbers. So here the result of addition will be 11924. Now similar process we will apply. So here the digit at units place is 4, so 4 will be multiplied by 4, so it will be 16, and this result of multiplication we will add with rest of the number. So here it will be 8, then it will be 1 2, so 1208. Now 1208, 1 from 1208, again we will choose the digit at units place, so it will be 8 4s are 32. So what we will do next is we will add 32 with 120, so it will be 152. Now 152, again if we are not sure whether it will be divisible by 13 or not, so what we can do one step further. So it will be 2 multiplied by 4, so it will be 8. Now what we will do, we will add 8 with 15, so it will be 23. Now it is clear that 23 is not divisible by 13, because here we will have remainder 10. So since 23 is not divisible by 13, so the given number is not divisible by 13. So this is the way how we check the divisibility of a given number, and we solve this type of sum. So I hope you have gained a good knowledge from this class. With this I end today's class. Thank you.